You all. In this session we are going to see about a binary multiplier. In the previous sessions we have seen adders. On adders we have seen off adder, full adder, then we have seen a parallel adder. After parallel adder we have seen BCD adder. Now in this session we are going to look after binary multiplier. Generally in the previous cases also we added 4-bit of information with the other 4-bit of information. Similarly I am going to consider two 4-bit of informations as A3, A2, A1, A0. The other number I am considering as B3, B2, B1, B0. So I am considering first number as A3, A2, A1, A0, second number as B3, B2, B1, B0. So let us see how these particular numbers are multiplied. Normally in the binary multiplier design we are going to use the same concept of decimal multiplication. Means I am going to multiply this A number as well as B number using a normal number. For example, if I am multiplying, you can see clearly A3, A2, A1, A0 is multiplied with B3, B2, B1, B0. I am going to multiply independently one bit with all the other bits of first number. So the first, when I am multiplying with the first numbers, this is going to be A0, B0, A1, B0, A2, B0, A3, B0. Done. After B0, I am going to shift one bit towards my left side, that is A0, B1, A1, B1, A2, B1, A3, B1. Next I am going to shift twice on my left hand side. So my things will be A0, B2, A1, B2, A2, B2, A3, B2. One more iteration. That is for my B3. That is A0, B3, A1, B3, A2, B3, A3, B3. So I am going to add them. If I am adding, I am going to get a product term. So those product terms I am going to represent as P0, P1, P2, P3, P4, P5, P6. Now if there is any carry, that will come under P7. That? But how to represent them? How to represent our product terms? Let's see with that one example. Like how the representation goes for P0. So P0 can be represented as A0, B0. P1 can be represented as A1, B0 plus A0, B1, A0, B1 plus A1, B0. Right? Next, P2. P2 is the three terms we are having. A2, B0 plus A1, B1 plus A0, B2. These are the things which we are having for P2. Coming for P3. So P3 can be represented as P3 can be A3, B0 plus A2, B1. Next, A1, B2 plus A0, B3. That. Next, coming to my P4. P4 can be represented as P4 is A3, B1, A2, B2, next A1, B3. Coming for my P5. So P5 will be A3B2 and A2B3. A3B2 and A2B3. My last thing is P6 A3B3. A3B3. When we are actually doing a multiplication between two 4-bit numbers, but at the end process is giving me a normal addition technique, which are producing a product terms. Means for getting all these terms, I can use a full adder. Let's see how when I put these terms onto a full adder, how does it look? Let's get onto it. Now, this is the architecture. I have kept all my terms from P0 to P7. I have kept my terms from P0 to P7. Now, I have kept my terms from P0 to P7. You can see clearly. So, B0, A0 I am taking directly. I am taking B0, A0 directly as first term. Second term, what I am doing is, for full adder, I have only two terms, B0, A0 and B0, A1. For along with the two terms, I am considering my carry value to be represented as a C0. Why? Because full adder has 3 input terminals. It has 3 input terminals. So that's the reason I am marking my C input value as 0 here. So that I am having 3 input values, which is generating me P1. Whenever it has a carry to be generated, that carry will be propagated to the next stage, where I am adding my P2 variables, that is B0 A2, B1 A1, which is giving me some value. Along with that thing, I am adding B2 A0, where I am giving my input value as carry for the next full adder as 0, which is generating me P2. This propagation of values along with carries will take place like this. As a stage wise, whatever the multiplication procedure we followed in previous case, the same stages I placed my full adders like this. So whenever I am placing all these full adders, it is giving me the values P0, P1, P2, P3, P4, P5, P6 and P7. So this is the architecture of binary multiplier, which is going to produce the product terms which are required by our binary multiplier. Okay, thank you.